Also came. Very good. So everyone is came. All 15 members. Do not disconnect, guys. Attendance is not even a secondary also. Not a primary, not a secondary. It is the least one attendance. But attend the classes is important. Okay. Attendance is for a tracking whether you are attending classes or not. Okay. But attendance is secondary. Like today attendance completed, we can leave, we can join tomorrow. It means to whom I am teaching, to you only, guys. So keep there only. And our class is very less at the time. So guys, recording is started, guys. So look at here, physical topologies and logical topology. Physical topology is telling the way you are connecting devices. Okay, the way you are connecting devices physically called a physical topology. The way of connecting devices, physical topologies. Logical topologies are is all about IP addresses, IP network wise only it is there. For example, you have a server. Sorry, that picture is belongs to server. You have a devices. For example, you have 100 devices are there. 100 devices are connected in a single physical topologies. But those can be able to divide logically. Okay. So physically, maybe it is the same network, but logically, it can be a different network. By how it is logically, we can able to divide using the IP address or IP network wise. That's a logical topology. So here we are discussing about a physical topologies only, the physical layout or physical connectivity in the network. The first one is bus topology, guys. Bus topology is very simple and very easy to configure. There is a backbone wire. There is a backbone wire. So devices are connected directly to this backbone wire. So every device is communicating through this backbone wire only. Okay, so that is much easy configuration. In olden days, we have a cable TV network. So that is a it's like a one single wire is draw, and from there it is connected. Even nowadays, this Geo fiber optical is also doing that kind of stuff only, but little different way, not exact way. Okay, so it is a bus topology. Usually that time they use a coaxial cables as a backbone wire, and this another coaxial cables are connected to this backbone wire only. Okay, using a connector like a T connector, BNC connector kind of stuff. So it is easy to configure, very less complex configuration it is. Easy to use also. But there is a one problem. If in case this backbone wire is stop working, then entire communication will stop. Or maybe in some place the wire is not working, like at sea the wire is broken. So further communication will stop automatically. So that is the problem with your bus topology. You and I shared this PPT, right? So here some description is also there. Please go through the descriptions. Next is the ring topology. Ring topology, every device is connected to the next device. Sorry, a device is connected to the next devices, and the next device is connected to another one. Finally, the last device is connected to the first device. Then it is a form a circle here, or a loop here, or a form a ring here. That is a ring topology. So A is send a packet to B, B send to C, C to D, D to E, E to A. That is a circle. Ring topology. It is also very easy to configure. It works based on an algorithm like how the configuration should be there, how the communication should be there. So we have to define in the each and every device. But what is one of the devices down, communication will stop. One way of communication will be stop. A wire is broken. the communication will stop. The further communication or a one way of communication may stop. Okay. Like a C is down. So A to D communication stop. A to B communication is there, but A to D communication will stop. D to A communication is there, but A to D communication will be stopped. So that is a ring topology. And there is another one. It's like a double ring topology, means two connections, and it is one connection is for clockwise, another one is anti-clockwise of communication is there. It may resolve this kind of stuff, but still there is difficult to scalability. Means you want to add more devices, again you have to change the entire configuration. That is a ring top. Mesh topology is a very beautiful topology. Mesh form like each and every device is connected to all other devices. Mesh topology is while telling a mesh topology, we draw a star first. Too easy to draw this mesh topology, but mesh topology is each device is connected to all other devices. Highly redundant, more reliable network. More reliable network. That is a mesh topology. Mesh topology. Okay. So problem with the mesh topology is it is a complex. It is a complex, but redundancy is wise good, because a device is down, remaining communication is going on. A wire is down, remaining communication is going on. Okay, so whatever it is, it happens, still the communication is never stops. That's why the mesh topology used in a highly redundant places, like in a server room, SAN, like a storage area network related kind of stuff. Okay, core routers networking related, that places people use the mesh topologies. In generally, we don't use ring topology, bus topology, mesh topology in a regular network. Okay, because mesh topology, even it is more reliable, but it is more complex. Lot of wiring is there, more lot of connectivity is there, and it is difficult to scalability. Means one more device is added, more number of wiring increases. Okay, it is a difficult to scaling. Means you cannot increase number of devices. That's a mesh topology. Next one is ring topologies. Sorry. Next one is star topology. Star topology is a little costlier than other, means bus topology, ring topology, mesh topology are directly cable based work. But in a star topology, we are using a centralized device. There is a device, all devices are connected to the central device only. Okay, it is a star topologies. Now, if a computer is down, the computer is down, no problem, remaining devices will communicate. Or a wire is down, no problem, remaining communication is going on. A central device like a hub or a switch, we are using hub, either hub or a switch we are using in a star topology. If that device is hub or a switch is down, entire communication will be stopped. So the star topology is non-reliable as a mesh topology, but it is simple to create it. Of course, you have to invest money on a centralized device, hub or a switch, depends upon the size of your network. You have to use it. Okay, it is a star topology, right? Non-reliable, and you have to invest money on the device called a hub or a switch, depends upon your network. But it is a very simple configuration, less complexity. It is very simple, or we can say it is very less complex. Okay, less complex. Second one is Manwar is there, right? Less complex, and it is very easy to troubleshoot. Okay, easy to configure and easy to troubleshoot. Why? Because of a device is down, it is connected to the hub or a switch, we can see the LED status. A device is down or a cable is down. So which device, which cable, we can able to understand what happened. Okay. So by LED status. Next one is if the centralized device is down, entire communication is stopped. So immediately you can understand by LED status, or maybe there is some device like a one part of network not working. So we can understand it is a switch problem, then immediately we can able to resolve it. Okay, so it is a very easy to understand, easy to troubleshoot kind of stuff, and it is very easy to scalable. Scalability is a one of the feature here. It is may not be reliable, but it is scalable. Scalability means extension of your topology. We can add more number of devices and create a larger the network also. So it is extended star topology. First part is star topology, second part is also star topology. I connect this switch to that switch, automatically it become bigger the segment or bigger the network. These are the main topology, guys. Bus topology, ring topology, mesh topology, star topology. Plus there is a hybrid topology. Hybrid means combination of mesh and star. Means I create a mesh topology is there plus star topology. Both are there. It is called a full mesh topology. Nothing but a hybrid topology. In another hand, hybrid means always combination of two or more things. Here one more is there. I am telling it is a point to point. Point to point means when you connect a device to another device directly, that is called a point to point. Like a router to router in the WAN communication, router to another router in the WAN communication, that is also a point to point. Router to multiple routers you are connecting, that is a point to multi-point connection. A switch to multiple devices, point to multi-point connection also there. Okay, so router to router, router to multiple routers, device to device, whatever it is, so point to point, mount to multi-point kind of stuff. Some people say like this star topology, bus topology, ring topologies are one to another one connection only. So obviously it is a point to point plus topology. That is also hybrid, but I don't know. But whatever it is, guys, these are the topologies. Tree topology. In the other hand, the tree topology is there is a backbone wire. Okay, and there is a different topologies. Networks are connected to this backbone cable. So like that, multiple things we can connect it. And on the other hand, the tree topology is like a one centralized device is connected to multiple switches or a router kind of stuff. Like in a, if you go to CCNA or a their routers and switches wise, the layers are there: core layer, access layer, distribution layer. Maybe that is comes under tree topology, because people are recently asking tree topology. This is best diagram tree topology. There is a backbone cable like a bus topology backbone cable, and different topologies are connected to this backbone cable as a branch wise. So logical representation. So bus topology, ring topology, mesh topology, and star topologies. Okay, so this is about your topology, guys. Of course, immediately it is a IP address related, but I am telling few things, guys. These are the networking based commands. Important network based commands are ping command, trace RT command, ping command, trace RT, ARP, route print. See, sir, what I told, sir, telling that one only. What is the issue with the candidates? So first point is said like SD batch issues, confidence fillers, manipulated sentences, frequent pausing, memorable moments. Okay, check the world questions. What are the questions you got it? Practice it, guys. If I don't have this PPT in front of me, I can also having some memory, but because of I am keep practicing, a maximum I will remember. But in a presentation to you, it may be difficult, but I can present without any object in front of me because of I practice a lot, I study a lot, practice a lot, I taught a lot time. So a lot of time have taken same class. Mostly I will remember. Okay. Same way, guys. You keep practice, so you no need to get a doubt in front of it, and practice without putting any PPTs in front of you. Just go to read once notes or something, whatever it is. You read once, go through question, read the answer, and practice by putting a blank screen in front of you, or record it if you want it. Okay, that is like you can hear the recording. Just you just read hear once more. Once you are recorded your answer, hear yourself. That will give you more confidence. So you can improve better. And second one is always best is put a one group meeting. Okay, daily meet. Daily you have to practice answering questions. That improves a lot. Okay, so ping test is a very good thing. Okay, so trace RT, netstat, ARP, root, netsh kind of commands we use it, and in ipconfig way, ipconfig space / all. These two commands to check the IP address. Of course, ipconfig all will tell you not only IP address, subnet mask, and default gateway. Also, it will shows DHCP server address, DNS server address. Okay, and lease obtained and lease expiry. DHCP enable yes or no kind of stuff, and of course you'll get your MAC address, physical address, and as well as your physical NIC description also you will find it. ipconfig space / release and / renew. These two commands, for example, you got an IP address and you are working good, but your network is changed. You are not your IP address is not updated. You change the network, and but your IP address is not updated. For example, I am sitting here. I got some IP address. I went to office. I will get another IP address, but I didn't get a new IP address. It is showing old IP or IP address. Then what I will do? I want to remove my old IP and get a new IP. ipconfig space / release or IP release. So then it will remove the already configured IP address to your adapter. But compulsory, it is automatic IP address. Manual IP addresses cannot be removed by this command. You have to remove manually only. ipconfig renew will try to get a new IP address from the DHCP server. ipconfig space / display DNS will tell the when you open any website, you got an IP address and name and IP address kind of concept. So that is the problem. Okay, so like you open youtube.com, then you will get a IP address of youtube.com from the DNS server. It will be stored in your cache, your browser cache only, the information stores. You want to see that one, so ipconfig space / display DNS. Try that command in your PC. ipconfig space / DNS. You want to remove that cache DNS data, that is flush DNS. Again, guys, what is this ping command? Ping command is to test the network between two devices. For example, I ping to my google.com. or a facebook.com. Meaning is, can I able to reach my google.com or a facebook.com? That is a ping test. Okay, ping means packet internet or a internetwork packet internet or a internetwork grouper or a packet
Sir,
internet.
one doubt.
Yeah, tell me.
In interview, they interviewer asked me what is data packets. Data packets. What is data packets?
What is the data packets? Uh, yeah, what is data packet means? Normally, generally packet means at network layer. If you add a source IP, destination IP to the segment, then it is called a packet. So the data packet means another one is there. Packet data unit is also there. PDU. Packet data unit. PDU. What is PDU means? In each layer, what are the type of data it is? What are the packet type it is? It is called as a PDU. For example, transport layer, it is add the TCP header to the PDU. What are the data it is? The data in the transport layer from transport layer is segment. The segment is PDU. Segment sent to the network layer and something will be added and come out with as the name is packet. That is also a PDU. Packet data unit means the data in the each layer. What are the form it is? Data in the each layer is called a packet data unit. Data packets means maybe the only data part in the packet. Maybe like original data packets means it's a complete packet. Means when you are sending a packet, we are saying in the normal language, from my PC to other PC, I will send a packet. Okay, the packet contains information, IP address, means source IP, destination IP, source MAC address, destination MAC address in it. That is one single packet. That's PDU what we are sending. That is a PDU. Packet data unit. Data packet. Packet, only packet. What is the only packet means? Source IP, destination IP, and segment called a packet. Source MAC address, destination MAC address, packet plus CRC called a frame from the data link layer. Okay. And in a ping, we are sending a 32 bytes of packet. Sorry, data size is 32 bytes. When you ping, so CMD, I'm pinging to www.google.com. So I want to check, can I reach this particular destination or not? I'm getting reply from google.com. It means bytes is equal to 32 means we are sending 32 bytes of data. The data size is 32 byte. Okay, and we are replying with a 32 bytes size only. Means you send 32, you will get 32 also. Of course, you can increase that size, but generally it is 32 here. Okay. So what is this ping? Ping does not have any abbreviation, but it is created abbreviation is packet internet or inter network grouper, packet internet grouper kind of stuff. Okay, but it is not originally an abbreviation or abbreviation people put it. A basic internet program that allow user to test and verify if particular destination IP address exists and can accept requests in a computer network administration. Okay, I am pinging to some PC like I'm pinging to my router, the same router or not router. So I'm getting request timed out also. So my router IP address is changed. 1 second, I will check my IP address. How to check IP address? IP config. Yeah, 0. This is my router address. Yeah, my IP address is changed again. Here I change my network. Request time dot is also a good one. See it is. I send a packet. I reply from the destination. Meaning is this IP address is existing. This particular IP address is existing, or the device which is having this IP address is also existing. IP address is existing, or a device with this IP address is existing, and the device is accepting our request. That we can able to understand using ping. So is a ping is a basic internet program that allow user to test and verify if particular destination IP address exists and can accept the request in the computer network administration. Ping works based on the protocol called ICMP protocol, Internet Control Message Protocol, ICMP protocol. Ping uses echo mechanism. Guys, you know the echo, right? So when you send it, you will get a same kind of stuff as a reply, right? So you send a echo request to the destination. For example, there is a two PCs, PCA and PCB. You send a echo request to PCB, PCB received it and a reply echo response to the PCA. It means you whatever the packet you send it, you will receive same packet only. You send 32 bytes of data, you will receive 32 bytes of data. So guys, here it is. To how when you are doing a pinging, you will get a different kind of outcomes. So one is reply from the destination type. Reply from the destination. You can see I'm pinging to this IP address. I'm getting reply from the destination IP. Here also you can see I'm pinging to google.com. First I got an IP address of google.com. Then I'm sending packet to this IP address and I'm replying an packet from this IP address. I send. It is showing only reply from the destination. It is showing reply from destination. Okay, so it means it's a successful ping. For example, you are getting a something like this: request timed out, a destination host not reachable. So I will show you request timed out later. 01 some IP address I'm trying to ping. Both are in the same network. You know, both are in the same network. How I know both are in same network? IP address 192.168.0 network I am belongs to this particular network 192.168.0 network. This is my network ID. In the same network, this is my IP address, my host address, this is network address. So with the same network only, I am trying to connect some device with this IP address. This is the host ID, this is network ID. So same network, different host. So I'm try to communicate with a different host. I'm getting this kind of IP address. It is 192.168.0.137, which is my IP address. This is my IP address. I'm getting reply from my PC only, not from destination. I'm getting reply from my PC, and also it is saying destination host not reachable. Destination host not reachable. Destination host not reachable. So why it is showing destination host not reachable and reply from my PC destination host not reachable means the host is may not be exist. The host is may not be exist in your network. Possible. Okay, host may not be existed, or maybe you enter IP address wrongly. The IP address is the not there, or maybe host is disconnected. Maybe host is disconnected. That system is disconnected. Our system is down. System is down. System is disconnected. Okay, system is disconnected. Our IP address is changed. That is no longer its IP address. Okay, it is no longer that IP address. Check the IP address kind of stuff also. So it is in a troubleshooting. If you got destination host not reachable in the pinging, so it is a possible your device is not there, or IP address is wrong, or maybe the IP address device is not there. A device changed its own IP address. IP address is different now, or maybe device is disconnected. So a lot of possibilities are there. Please verify that one. Next one is request timed out kind of stuff. Request timed out. So when I'm trying to ping some device, so we'll try some device. Okay, either I will get a destination host not reachable. Okay, no problem. So I'm getting a request timed out kind of stuff also. You can see here it is. I'm trying something. So I'm getting request timed out. Just for a show output only, guys. Not what is the ping part here. Point is only outcome request timed out. So if you are trying to ping to some device, you have already checked the device is there, device is connected, device is available, both source and destination are in the same network, both source and destination in the same network, same logical network, same physical network. So when you try to ping from source to destination, you are getting request timed out. So there is a possibility firewall is blocking your request. So every PC in the Windows PCs, by default, we have a firewall inside. Okay. So every PC in Windows, by default, firewall is there. So this firewall does not allow incoming packet. Like you are sending a ping request in other side, that system's firewall will does not accept the packet. Okay, that is a possibility. Okay, so it is a one of the reasons. So request timed out means generally request timed out means in generally same as a destination host not reachable kind of stuff. Okay, like a device is not available, a device is down, a device is disconnected, or IP address wrong, or wrong network IP address it is, wrong network IP address it is. So in that cases you will get a request timed out. Wrong network IP address. Here it is wrong network IP address. IP address I given, that is a not in my network. Not in my network. So obviously I will get a request timed out. Or destination host not reachable or a request timed out. Next one is in another cases, if all are good but still you are getting a request timed out. Why? Because of here your firewall is blocking your ping request. So this is the way of troubleshooting, guys. Understand with the ping. Okay. So ping is good. Reply from the destination. It is a good one. Okay. Ping is good. It is good kind of stuff. You are getting destination host not reachable and ping reply from the yourself IP address destination host not reachable. It is a possibility of the IP address. Check your IP address connections. It is a device status also. Request timed out is same as a destination host not reachable plus firewall setting also verify. Okay, and also make sure in the request timed out make sure your IP address is in the same network or not. Okay guys, that is a ping test related. Trace RT. Trace RT will tell you how do you reach the destination. Trace RT will tell you how do you reach the destination. Okay, how do you reach the destination? Okay, so I am here in my PC, my destination, like for example, google.com, facebook.com, youtube.com, somewhere in this world, right? Not in my network, not in my next network, not in my nearest network. It is located in some different geographical location. Now I want to know how I reach that destination. So how many routers I crossed to reach the destination? How many routers I crossed to reach that destination? For example, trace RT google.com. I am reaching google.com. I'm getting web pages from google.com. Means it is how I reach the destination from my PC to my router to ISP's router, ISP router to another router, and then it is public some routers, and then router. Finally, we reach the destination. See, it is trace RT, ping and trace RT. Two networking commands I told you. So we don't have time to discuss all other kind of stuff. You want to manage your network like IP address, subnet mask, or like that using command prompt. You can use netsh command also. But without knowing anything about netsh, don't touch it. It is very easy, but need a practice. Oh. Already I reached 8. This is 9th one. So by 9 steps, I reach the destination. Okay. So this is a trace RT. Okay, guys. Anytime we get a network related issues, different type of network related issues are there. The first one, so how to solve this network related issues, we can find it. Of course, generally I will tell about SOP, standard operating procedure. Okay, SOP is there, standard operating procedure to resolve any issues. But here I am telling directly, so not discussing about SOP. So OSA layer wise troubleshooting, guys, and also it is repeats here OSA layer also. Application layer, presentation layer, session layer, transport network, data link, and physical layer. OSA layers are a 7 layers. OSA layers are a 7 layers. Application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Totally 7 layers are there. Some people having a hobby of reading and telling from bottom to top, like a physical layer, data link layer, network layer, transport layer, session layer, presentation layers, application layer. Which one is correct? I say both are correct. It depends upon certain textbooks. It is showing in a physical layer to application layer. In some textbooks, some hobbies, so it is application to physical layer. So something is correct does not mean other one is wrong, or something is wrong does not mean other one is correct. Okay, and each layer roles and responsibilities also there. Like a physical layer is all about a physical connectivity. Application layer is all about a application in a network end. Okay, see that one. I have a web browser. In the web browser, I am accessing website. In this web browser, I am accessing the website. In this web browser, I am accessing a website. Okay, so what I'm doing, guys, yeah, web browser is an example for application layer. FTP, like a FileZilla. So I will show you that one. FileZilla is an application for a FTP related client. Of course, there is a servers also there, like a web server, file server, mail server, Outlook as a mail client, Outlook mail client. So this is a mail client software. Using this, I'm able to send and receive a mail. See this? Application layer is all about a server side application and a client side application, and the protocols and their port numbers. Different protocols are there, and there is a different port numbers for each protocol is there. Each protocol having a port number is there. Okay, so that is application layer 2. Presentation layer is um, presentation layer is about a encoding and decoding of a data. Means what are the data is format. It is encoded into ASCII format, and compress the data, decompress the data, encrypt the data, de-encrypt the data. Session layers is about to create a session, maintain a session, and terminate the session. Like you open a web page, you open a web page like a web, like Gmail account you open, or maybe YouTube you open, or a Facebook you open. So you are sending a request, and then before you send a request, you will create a session. You send a request to the server. Server received your request and give some response to you. Then you load the page. You got what are the information you are sent. You got it now in the client. So once you got it, the session will be completed. The session is created, maintained, and terminated. If you change the network in middle of some session will be expire in middle only. Or maybe you disconnect and connect the network, the session may expire in middle of the session. So please careful with the session layer also. Transport layer is more about a error correction, numbering and sequencing. Okay, so it chop the data into segments, and it will put a number on it. Because smaller data faster you can able to send it. Like you ask like a what is for packet data, so that is like it is chopped big data into small data, that is process we call it as a segmenting, and we are add a numbering on it, and we multiplex TCP UDP protocols into TCP and UDP side. This entire data information, we call it as a segment. Like a TCP header is added to your PDU, the total data is called a packet data unit. This segment will forward to the network layer. But before that one, so in transport layer is also we are discussing about a TCP UDP. This is also a question. What is TCP? What is UDP? Guys, we have a lot of protocols like this: HTTP protocol, HTTPS protocol, FTP, SSH, Telnet, RDP, SMTP, POP3, IMAP, TFTP, DHCP, DNS, NTP, Kerberos, LDAP, and SNMP. So not only this, there is a lot of protocols are there. Each protocol has a registered port number is also there. Okay, maybe some protocols may not have a registered port numbers, but or some port numbers not belongs to any particular protocol also. Possibility is there. But here again, I'm telling guys, each protocol having a dedicated port number is there here. Okay, like this. HTTP means web related request. I want to open a web page like this. I want to open a web page. I send a request with the HTTP. Then what is this HTTP? Yes. What is HTTP? Yes. HTTP is a plain text format. So data in the web page is not encrypted data. It means, so while data is transmitting from server to client or a client to server, client to server, data is not encrypted. Example, guys, in your WhatsApp, maintain end-to-end encryption. For example, you put a text message on your WhatsApp, the data is encrypted and sent. Even the middle server also don't know what is the data in your packet because it is encrypted. So it will be decrypted at end of the user only, end user end only. So encrypted and decrypted. So HTTP and HTTPS, HTTP protocol send plain text data. So HTTPS protocol will transferring and receiving a data using encrypted format. Same goes for different protocols and their port numbers like FTP 2021, SSH 23, Telnet 20. Telnet is 23, SSH is 22. Again, SSH and Telnet are remote access protocols, but SSH is an encrypted format, Telnet is not an encrypted format. Okay, RDP, remote desktop protocol, SMTP 25, POP3 23, IMAP version 4 143. POP3, IMAP, and SMTP, all these three are mail communication related protocols. POP3 and IMAP are a receiving purpose, as SMT is for a sending purpose. TFTP, Trivial File Transfer Protocol, DHCP, Dynamic Host Configuration Protocol, DNS, you know already, DNS, Naming Service Related. NTP is a Network Time Protocol, Kerberos and LDAP, Authentication Protocols. NTP, Network Time Protocol. SNMP, Simple Network Management Protocol. Guys, these are the protocols and port numbers. Your application layer also dealing with that protocols and port numbers, and application side of client and as well as a server side. So this presentation layer is dealing with presenting data, means encoding, decoding kind of stuff. Compress, decompress, encryption, de-encryption stuff. Session layer. Okay, yeah, session layer. We will create a session, and until you receive your request from the remote server, the session will be key. Okay. Simple example, I will tell a session layer, guys. When you do payment, like you purchase something in Amazon, you given all the details, everything is completed. Now payment is going on. You will get a message. Do not refresh your browser or do not press the back button. Why it is? Because all your entire transaction is going with the one single session ID. If you refresh or you press the back button, the session ID will be changes. So the transaction may failure or maybe you will get a problem with it. Okay. So here again, so we are forgetting one point here, that is TCP UDP. That's where what I'm trying to explain. Then I will go to the point protocols and kind of stuff, because that is important, guys. Different type of protocols and port numbers, but some protocols are TCP type protocol, some are UDP type protocol, some are TCP type protocol, some are UDP type protocols. What is the difference? TCP type protocol like HTTP, HTTPS, FTP, okay, SMTP, these protocols are TCP type protocol. The behavior of a TCP IP protocol is acknowledgement based behavior. Packet will be sent source to destination. Destination received a packet and destination reverse. Destination will give a packet to the source send a packet to destination. Destination returns an acknowledgement. Destination returns a acknowledgement. So then source understand destination received a packet. Now you will get a delivery message, right? You will get a delivery message. Yes, deliver successful. Transaction successful. So we'll understand, yes, it is transaction is done. Okay, that is a TCP type. Again, if you don't get acknowledgement from destination, you didn't get any acknowledgement, it means you have to send the packet again. As a source, you have to send the packet again. So that is a destination host not reachable. Okay, sorry, my mind full sleeping time. Another batch is also starting at 3:30. New batch that too. Yeah. Again, TCP UDP guys is important. Transmission control protocol, user datagram protocol. Different protocols we use in the network. Some protocols are TCP type. Some protocols are UDP type protocols. So what is the difference? So TCP type protocols behavior is acknowledgement based behavior. It means when it is send a packet to the destination sent an acknowledgement to the source. So source understand packet is delivered. Source understand packet is delivered to destination. If source does not receive an acknowledgement, source does not receive an acknowledgement. Source does not receive an acknowledgement. Okay. Source think destination does not receive a packet. Again, it will send a packet, same packet, it will send it again. Because of it is a transport layer responsibilities, the packet will be rearranged again based on the numbering and sequencing order, it rearranges. So that is the TCP type of protocols. UDP type protocols is a behavior is like this, no acknowledgement here. So like a TFTP, DHCP, DNS protocols are TFTP, UDP type protocols. Meaning is packet source send a packet to destination. Destination received or not, source does not know. So we send a packet, whether it is received, not received, we don't know. So we'll keep send a packet on. So that is the behavior of these protocols. Okay. Lot of people think in a different ways, but simply guys, TCP is a one kind of protocol, UDP is another kind of protocol. There is a type, different protocols are there. Some are TCP type, some are UDP, some are both. Some are both. Both behavior is also there. Okay. Next one is TCP is reliable, UDP is non-reliable. Why reliable, non-reliable? Source in TCP type protocol, source knows destination received a protocol. Destination received a message. Source knows destination is received. Destination is received a packet. Source knows it. In UDP type protocols, source does not know destination received a packet or not. Okay, this is the second. Reliable, connection oriented, connectionless. Connection oriented packets are like this. Connection oriented kind of packets are like this. Okay. So what is a connection oriented? Connection oriented is go through like this. Connection oriented means not a wide or a wireless kind of concept is. Connection oriented. Why connection oriented? We call it as because source knows destination received a packet based on the acknowledgement. Means it is a two-way communication. Source sent, destination received, and destination will send a acknowledgement. Means both ways, send and receive kind of concept is there. That's why it is connection oriented. Connectionless means it's both side communication is not there. Means sending and receiving, send, send only. Receiving is there or not. Receiving yet we don't see. You only sending. That's it. We don't mind about receiving. Send and receive is not working in a UDP. Either you send, that's it. Okay, you will send a packet. Destination side received or not received, we are not getting that information. That's it is connectionless. You know, one day I have seen one question in a previous means 2 years back interview question. UDP is a connectionless, then how it is connected? UDP is a connectionless protocol, and it is how it is connected. Means there is nothing like that, guys. There is no connectionless, connection oriented kind of stuff. It's a type is connectionless type. Means receiving, send it will send a packet. That's it. Received or not, we didn't check it. That's it is connection less protocol. That's it. It's not like a wired or wireless kind of stuff. For example, I'm using a wireless internet. I'm using wireless internet and I'm using HTTP protocol. It is working, right? Like that. So how much time? It is 3:30. Last two are there. I will tell and I will close. Tomorrow I will tell questions and answers wise only, guys. So that is a very simple one. Network layer. Yeah. New batch people also adding. Guys, you can just give me a 5 minutes to start next one. Let me finish this one. Okay. Network layer is dealing with the IP addresses. So from your transport layer, the packet we are transmitting our PDU packet data unit is called a segment. That segment is sent to the network layer. The network layer is getting added with the routed and routing protocols. Routed means IP addresses like IPv4 and IPv6 addresses. Routing protocols about a routing information from different routing protocols. Okay, like RIP related information or EASIP related information, OSPF kind of information. So mainly like the network header will be added to your segment, then it is called as a packet. The network header means source IP address and destination IP address. So network layer is dealing with an IP address. That's why router is a network layer. Remember, router is a network layer because router understand both IP addresses and routing protocols. Router understand both the things. That's it. It's a pure network layer. Next one is, yeah, of course, we call this one source IP, destination IP to the segment is called a packet. Or PD is a packet. The packet sent to data link layer. In data link layer, actually having two sublayers. One is LLC, link logical link control. Another one is a MAC. MAC address is a physical address, media access control. MAC address is a 48-bit address. It represented in 12 hexadecimal, also called as a physical address. Source MAC address, destination MAC address will be added to the packet as a data header, and as a tail, it is CRC. Cyclic redundancy check is an algorithm which checks your data at a destination. CRC value will with CRC value, it will check whether data is good or not. Error checking purpose. So your data link layer is error checking. Error correction is network transport layer error correction. Data link layer error checking. So this total packet, like a source MAC address, destination MAC address, packet, and CRC combined, we call it as a frame, or PD is a frame, packet data unit is frame. Frame sent to the physical layer, frame is converted into the bit stream. The bit stream again convert into electrical signal, radio signal, light waves, whatever it is, depends upon your media. Guys, I have a laptop. I connected with a Wi-Fi. I connected with a Wi-Fi adapter, right? Through wireless, means it is a radio wave. For example, if I connect with a LAN wire, I took a LAN wire, or UTP wire. Okay, I connect with a LAN wire to my LAN adapter. Electrical signal. Okay, of course, my laptop does not have any fiber channel kind of connectivity. If I have a fiber channel kind of connectivity, then the signal is converted into light waves. The physical layer is convert your frame into bit stream into that based on the media we are using. So it will convert into that signal. So these are the OSA layers. So each layer wise also you can understand different troubleshooting. Physical connectivity means physical layer. So two systems are not communicate each other. Check the physical connectivity. Okay. Next, IP address. Check the IP address. Check the firewall. Check encrypted or not encrypted protocols like HTTP, HTTPS protocols. I will forward one video. Last Friday I have taken a class, network based troubleshooting, guys. That is also, I will check it. Very recent history only, you can get it, that one. Okay. My videos only recent. If you go to recent one, so N7 batch, you will get that. Okay. Encryption, no encryption. HTTP, no encryption. HTTPS, encryption. So HTTP website cannot be opened with HTTPS protocol. HTTPS website cannot open with the HTTP protocol. Okay, so these are the things. Next, sometimes you are unable to send and receive a mail, application layer problem. You are unable to open a website. You open a website, it is showing page not found. Page not found means internet is there, but web server error or URL error, means what are the web URL you are giving, means this address, what are the address you are giving, that address is wrong. Page not found means address is wrong. I use this example on here. I'll try always in this one only, like this. Means the URL is wrong. I am getting this, sorry, 401, 404, page not found error. Okay, it is URL wrong, or remote server is wrong. Okay, or a remote server is down, or page is not there, or maybe your entered URL is wrong, but not internet one. Sending and receiving a mails, also same problem. Okay, so this is it, guys, for today. So I said tomorrow also there, but tomorrow I need a questions. What are the questions? Directly question wise, differences wise, I will explain, not a complete topic wise. Okay, check it tomorrow. If you have a further sessions are there or not, tomorrow we will discuss that one. That's it for today, guys. Yeah, no problem. So the B4 batch, guys. That's it for today, and